Hi everyone. Do you see the steam coming from this water right here? You may not because of the video camera, but this water is really, really hot. I'm going to take this beaker and I'm going to fill it with water from this sink. And I'm using my hot hands to make sure that I don't burn myself on the outside of the beaker. As I mentioned, this water is extremely hot. While I fill this up, it is important to note that today we're going to be talking about how to measure temperature. So we're going to start by measuring the temperature of something hot, like this boiling water, and then measuring the temperature of something cold, which we'll take a look at in a little bit. Looks like we're almost about full. There we go. You've got a beaker in front of you with some really, really hot water. Let's check out its temperature. But I'm going to do this so that you can get a really clear view of how I'm going to measure the temperature. I'll do that using a thermometer, like the one that you see right here. Let me step away so that you can see. I'll put it inside the liquid. And if you look really closely, you may see that the liquid inside the thermometer is starting to go up. It's rising a little bit. And it's continuing, this red liquid, to go up through the thermometer. It looks like right now it's about leveling off at a little bit under 70 degrees Celsius. I'll call it roughly 68 degrees Celsius. Now let me move this aside. I'm going to immediately replace that container with some cold water. Let's watch the thermometer again in the cold. You immediately see it start to go down. In fact, you might not even see the red liquid anymore. It is dipped well below the ice level in this container of really cold water. I'll give it a second to level off, and then we'll take the reading on our cold water as well. I'm getting a reading of, it looks like 5 degrees Celsius. So, 2 containers of water, one that was really hot, that measured roughly 68 degrees Celsius, and one that was really cold, that measured 5 degrees Celsius. Today, we're going to talk about measuring temperature and how the first thermometer was created. Now, the experiment you just saw me do, sticking the thermometer in really hot water and really cold water, was done a couple hundred years ago. And it wasn't done just for fun. It was done by a man by the name of Anders Celsius. And Celsius took a tube that had a little bowl on the bottom and that rose straight up. And he filled the tube with mercury, a substance that could expand very readily when it was heated. So when mercury got hot, it would grow and get bigger. And so he filled up his tube with a bit of mercury. Then he took this tube and he stuck it in boiling water, even hotter than the water that I just used in the laboratory. This water would be like if you went to make pasta and the water was boiling and evaporating as it sat there on the stove as you got the water to boil. It was so hot that it caused the mercury to rise in the tube. And Celsius's tube was blank. It didn't have any markings on it. And so he decided he was going to make a mark on the tube. He wrote next to that mark 100. And then he decided he was going to call this 100 degrees Celsius. He named it after himself. What Celsius did next was very similar to what I just did. He then took the water and he put it in a bath of ice. So, I'm sorry, he took the thermometer and he put it in the bath of ice. And so the mercury level dipped way down when it was in the ice. In fact, this ice was even colder than the ice water that I had in that example. It was just about frozen. And so when Celsius did that, he noticed that the mercury contracted, meaning it got smaller, and it dropped down to this level right here. He wrote next to that, 0. 0 degrees Celsius. Then he made a bunch of lines in between. In fact, he made there be 100 spaces in between the 0 and 100, with each space representing 1 degree Celsius. So Celsius now had a way to measure the temperature of something. All he needed to do was look at how high the mercury went up. And as a result, he could figure out how hot or cold the water was compared to his ice water and his boiling water. Now, Celsius was not the only scientist who had a similar idea like this. In fact, a very similar experiment with a long glass tube that was filled with some mercury was done by another scientist right around Celsius's time. This scientist placed his tube in boiling water as well, and the mercury rose up as it expanded and got bigger. And just like under Celsius, this scientist also put a line at the top. However, he didn't write 100. He chose a very random number. He wrote the number 212. And then he also named it after himself. He said that it's going to be 212 degrees Fahrenheit. This scientist is named Daniel Fahrenheit. Then Fahrenheit did the same thing as Celsius. He took his container, he put it in an ice bath, and the mercury level dropped down really far as the mercury contracted and got smaller. Went to the same level as Celsius. Can you guess what Fahrenheit labeled his thermometer? If you said 32, you'd be right. So Fahrenheit's scale went from 32 to 212. The reason behind these numbers doesn't make a whole lot of sense based on our class right now. I wouldn't worry too much about it, other than to realize that the Fahrenheit scale has some pretty funky numbers. That's why I like to use the Celsius scale. It goes from 0 to 100. It's very easy to figure out. Now, as you might have guessed, there was another scientist who did the same thing and repeated the same process. This scientist also took his tube, filled it up with mercury, and then stuck the tube in some boiling water. And as a result, the mercury rose up. And just like Celsius and Fahrenheit before him, this scientist also made a mark. However, this time the scientist picked a very strange number, 373.15. Now, this scientist also skipped the little degree symbol, and he named it after himself. This scientist is Lord Kelvin, and the K stands for Kelvin, Kelvin. Lord Kelvin then did the same thing as Daniel Fahrenheit and under Celsius, and he stuck his thermometer in an ice water bath. And as a result, the temperature dropped down. The mercury contracted, he made a new mark, and he wrote 273.15 Kelvin. So 3 scientists who found temperature three different ways. Under Celsius, Daniel Fahrenheit, and Lord Kelvin. So, which temperature scale should we use when making measurements of temperature in science? Well, there are advantages to using each of the scales. The Celsius scale goes from 0 to 100 for the freezing and the boiling points of water. And as such, it's a really convenient scale to use because we can very easily associate freezing or anything colder than that as being below 0, and anything in the triple digits above 100 degrees Celsius as boiling. It makes a lot of sense. The Fahrenheit scale seems to make very little sense. However, in the United States, most TV news stations will report temperatures in Fahrenheit. And so we're very used to temperature being measured in Fahrenheit. For example, if somebody tells you that it's going to be 75 degrees and sunny, they're likely measuring the temperature in Fahrenheit in the United States. We know that a 75-degree day is very nice out, whereas a day that's 40 degrees out might be a bit cold. And then lastly, the Kelvin scale. What's the point to that? Well, the nice thing about the Kelvin scale is that there are no negatives on this scale. In fact, the coldest temperature you can get in the world is 0 Kelvin because the molecules stop moving completely. That's called absolute zero, and maybe you've heard of it before. At absolute zero, the molecules stop moving, and there cannot be a lower temperature than that. So to summarize, Celsius is great because it goes from 0 to 100. Very logical. Fahrenheit is what we're used to in the United States, so it's very familiar for a lot of people. And lastly, Kelvin never has any negative numbers, which is great, especially if you hate dealing with negatives. Now, one annoying thing about having three different temperature scales is that we have to know how to convert between them. Scientists will typically measure temperature in Kelvin to avoid the negative numbers. However, a lot of times you will see scientists measure in Celsius. But for us, we might need to convert temperatures into or out of Fahrenheit. So we need to learn about some conversions between these different scales. Let's first talk about going between Celsius and Fahrenheit. Let's say that you're given a temperature in Celsius and you want to convert it into Fahrenheit, something that you're a little bit more familiar with. You would do this. You would take 9 times the temperature in degrees Celsius, divided by 5, and then add 32 to get your temperature in degree Fahrenheit. I would write that down somewhere if I were you. 9 times the temperature in Celsius, divided by 5, plus 32, equals the temperature in Fahrenheit. So let's do an example with that. If I were to have a Celsius temperature, let's say of 15 degrees Celsius, I would find the temperature in Fahrenheit by doing 9 times 15 divided by 5 plus 32. Using my calculator, I would find that that is a temperature of about 59 degrees Fahrenheit. Maybe about the temperature of a nice fall afternoon. 15 degrees we normally associate with being cold, but 15 corresponds to 59 degrees on the Fahrenheit scale. Let's say we wanted to go the other way around, and we had a temperature that was in degrees Fahrenheit, and we want to convert it to degrees Celsius, perhaps to use in a scientific experiment. Or maybe your friend in Canada who uses Celsius asks you to convert the temperature. Well, you would take 5 times the temperature in degree Fahrenheit minus 32. Then you would divide the whole thing by 9. A little bit different than the Celsius formula. This will give you an answer in degrees Celsius. So 5 times the temperature in Fahrenheit minus 32, which is in parentheses, divided by 9 will give you your temperature in degrees Celsius. Let's do an example. Let's take that beautiful 75 Fahrenheit day that we were talking about before. 5 times 75 minus 32 divided by 9. Doing our math gives me a temperature of 23.9 degrees Celsius. If someone tells you it's about 24 degrees Celsius, it's actually a really nice day, even though 24 degrees sounds really cold to us if we aren't specific about which units we're using. Let me give you a little rhyme that I heard that might help you understand how to go from Celsius to Fahrenheit. Somebody once told me that if you're talking about temperature in Celsius, 10 is cold, 20 is not, 30 is warm, 40 is hot. How does that make sense? I'll say it again. 10 is cold, 20 is not, 30 is warm, 40 is hot. So remember how at the beginning of the video, I had that really hot container of water that was at 68 degrees Celsius? That means it'd be off the charts hot. So that just goes to tell you how hot that temperature really was. If you're in Canada and it's a 40 degrees Celsius day, better take out your swimwear and hop in a pool somewhere. Because even though it's 40 degrees, which to us sounds cold, in Celsius, that's actually really, really hot. Let's talk about the other two temperature scales. We know how to go between Celsius and Fahrenheit, but what about if we were talking about the two scientific temperature scales, Celsius and Kelvin? Well, to do that, it's a pretty easy conversion. So you might see that the freezing point for water is 0 in Celsius, but 23.15 in Kelvin. All you need to do if you have a Celsius temperature is add 273.15, and you will get your Kelvin temperature. So if you were to have a 30-degree warm day in degrees Celsius, and you add 273.15, you will get an answer of 303.15 Kelvin. That's a warm day. 303.15 seems like such a big number, but that's because it's measured on the Kelvin scale versus the Celsius scale. Going the other way around is really easy too. Let's say that you have a temperature in Kelvin and you want to convert it to Celsius. Just subtract 273.15. So let's say that you have a temperature of 360 Kelvin. If you want to find out what that is in Celsius, just take that number minus 273.15 and you will have your answer. So let's do that. 360 minus 273.15, and this would mean a Celsius temperature of 86.85 degrees Celsius. Might seem like just a typical hot day, but remember, that's Celsius. This is a super, super high temperature. Not quite the boiling point of water, but really, really hot. So as you can see, thermometers have been created and have been around for hundreds and hundreds of years. Thermometers work by placing them in an area that has a certain temperature, perhaps inside a liquid, and watching the liquid inside rise and fall. There are 3 different ways that we can measure temperature using thermometers: in degrees Celsius, degrees Fahrenheit, and Kelvin. And there are different ways that we can convert between them. which we'll be practicing next time that we're in class. However, what you need to know is that Celsius and Kelvin are the more scientific ways to measure temperature, and we'll be using those a bit more. Even though you might be unfamiliar, remember the rhyme that might help you. On the Celsius scale, 10 is cold, 20 is not, 30 is warm, 40 is hot. Thanks for watching. Oh, hi, it's me again. I'm glad you didn't stop watching. Well, here's something that may help you out since you made your way to the end of the video. These are the formulas that we talked about. Degrees Celsius to Fahrenheit, degrees Fahrenheit to Celsius, degrees Celsius to Kelvin, and Kelvin to degrees Celsius. I put them all in one place for you here at the end of the video. If I were you, I might take these down in your notes because we're going to practice with them. So while everyone else is scrambling to get their equations all together in one place, here you have them all set and ready to go. Thanks for watching through to the actual end.